Section 3.1 Quadratic Functions in Standard Form. A quadratic function in standard form is given by f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. We can complete this square and write the function as f of x equals a times the quantity x minus h squared plus k, where h comma k is the vertex of the parabola. If a is greater than 0, in other words, a is positive, the parabola opens upward, and if a is negative, the parabola opens downward. Let f of x equal 2x squared minus 12x plus 23. We are asked to express f in standard form. First, we need to complete the square by pulling out the leading coefficient. And then we take half of negative 6 and square it and add it to the set of parentheses. But technically, we've added 9 times 2, so we need to subtract 9 times 2. And if we simplify, we get 2 times x minus 3 squared plus 5. And then we're asked to find vertex, x-intercept, and y-intercept of f of x. So the vertex is h comma k, as we saw in the previous slide. So h comma k in this case is 3 comma 5. The leading coefficient is positive, and the parabola opens upward, starting at 3 comma 5. So we can see that there is no x-intercept because the graph will never get to the x-axis. We can see this by doing some algebra as well. 2 times x minus 3 squared plus 5 has to equal 0, which we can see that this cannot happen. Y-intercept is when x is 0, so f of 0 gives us the y-intercept at 23. Then we're asked to sketch the graph of f. So we plot the vertex and the y-intercept. Again, we don't have any x-intercepts in this case. And since parabolas are symmetrical about the line that goes through the vertex, we have this parabola opening upward. Then we're asked to find domain and range. The domain is all real numbers for all polynomials. So in this case, domain is negative infinity to infinity. And the range is from the lowest point to infinity, and the lowest point in y value is 5, so it's from 5 to infinity. Minimum and maximum of quadratic functions are at the vertex of parabolas. So if a is greater than 0, there is a minimum at f of h equal k. And if a is negative, there is a maximum at f of h equals k. Given a quadratic function f of x equals ax squared plus bx plus c, the first coordinate of the vertex is h equal negative b over 2a, and the second coordinate of the vertex is k equals f of h. So instead of completing the square, we can use this formula to find the vertex. In this example, we are asked to express the function in standard form, so we need to first complete the square, which we pull out the leading coefficient and take half of 4 and square it and add it to the first set of parentheses. Technically, we added 4 times negative 2, so we need to subtract 4 times negative 2. This simplifies to f of x equals negative 2 times x plus 2 squared plus 7. Now we're asked to find vertex, x-intercept, and y-intercept of f of x. The vertex is at negative 2 comma 7. X-intercept can be found by simply using quadratic formula on the original f of x, which simplifies to negative 2 plus or minus square root of 14 over 2. And the y-intercept is when x is equal to 0, so f of 0 equals negative 1. Now we're asked to sketch the graph of f of x. First, we plot vertex, x-intercepts, and y-intercept, and since parabolas are symmetrical, and we know that this parabola is opening downward because the leading coefficient is negative, we get this parabola. And to find the domain and range of f of x, we can see that domain of all polynomials again are negative infinity to infinity, And the range in this case would be from negative infinity to positive 7, including 7. Here's another example. Most cars get their best gas mileage when traveling at a relative modest speed. The gas mileage m for a certain new car is modeled by the function m of s equals negative 1/28 s squared plus 3s minus 31, where s is the speed in miles per hour and m is measured in miles per gallon. What is the car's best mileage and at what speed is it attained? Using the formula that we just learned, we can find h by simply plugging b and a into the formula to get 42. Now, we find m of 42 to find the second coordinate of the vertex, which we find it to be 32. So the car's best gas mileage is 32 miles per gallon when it is traveling at 42 miles per hour.